Hello class. Today we're doing Unit 1, Lesson 8, Compare and Order Irrational Numbers using a number line. Problem number 1 says we have square root of 13, 3, square root of 11, and 4. And our instructions are place the numbers on a number line, then compare using an inequality. So looking at square root of 13, on our chart here, perfect squares, that's going to fall between 3 and 4. Between the 9 and the 16, we have square root of 13. So that's going to be between 3 and 4. And square root of 11 is also going to be between 3 and 4 because it falls in between square root of 9 and square root of 16. So I'm going to use 3 as my lowest, 4 as my highest. 3, which is equivalent to square root of 9, and up here 4, which is the square root of 16. Then in between, I'm going to put square root of 11 and square root of 13, as it goes in numerical order. 9 to 11, 13, 16, just like our chart. It starts off with 1, and all the way down here for 13 is equal to the square root of 169. So it's all going in order. So I'm putting my little dots down for my number line, and then my inequalities would look like this. And rewriting that, that would be 3 is less than square root of 11, which is less than the square root of 13, which is less than the square root of 16, which is, well, let me write it the way they have it in the book. I want to go off the 4. So I got them all lined up from least to greatest. So that's problem number 1. Problem number 2. We have square root of 53, 8, square root of 65, and 7. So again, looking at our numbers, 7 and 8 gives us a range of 49 to 64. 53 falls within that range between 49 and 64, but 65 goes just over square root of 64, which is 8, so square root of 65 is going to be just a little bit more than 8. So I'm going to start off my number line here. So down here we're going to have 7, which is equivalent to square root of 49. And then over here we will have 8, which is equivalent to the square root of 64. And then 53 will go in between here. And then square root of 65 is going to be past the 8. Like so. So going in order again. 7, which is the square root of 49, then 53, then 8, which is the square root of 64, then our last one, square root of 65. So writing it out using inequalities, 7 is less than the square root of 53, which is less than square root of, again, here I go, write square root of 64. Just write the 8, which is less than square root of 65. All right. So again, we're using the numbers they provide us and comparing them against a chart of perfect squares. Here I got one from 1 to 13. Hopefully you have one as well. If not, write it down. Problem number 3. We have square root of 2, 2, square root of 3, 3, square root of 2.5. So looking at our numbers again, square root of 2, well, here's square root of 1. So square root of 1 is 1. And then go up to square root of 4, which is 2. So square root of 2 is going to fall between 1 and 2. Square root of 3 is also going to fall between square root of 1 and square root of 4, which is between 1 and 2. Then we have a 3. And then we have square root of 2.5, which is again going to fall in between the square root of 1 and square root of 4. So I need a number line that's going to range from 1 to 3. All right, so now let's start placing them out. So in between all of these should be 2. So we have a dot here. And we have 3, which we need a dot here. And square root of 2 is going to fall between the 1 and the 2. So I'll go ahead and put a dot right here for square root of 2. And we have the next one, because we didn't get to 4 yet, square root of 4, which is equal to 2. So I'll write square root of 4 right here. We need to have square root of 3, which come in between the square root of 2 and square root of 4. And in between these two, we need to put the square root of 2.5. So I'll write a little line down, 2.5. So we have 1, then our first number starts with square root of 2. Then we go to our next number to square root of 2.5. The next number to square root of 3. And then we have the full value 2, dot here. And then we have whole number 3. So we got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We got them all marked. So now let's put them in numerical order here. So square root of 2 is less than square root of 2.5, which is less than square root of 3, which is less than 2, which is less than 3. All right. Next, problem number 4. We have root 63, root 57, root 35, root 41, and root 101. We've got a whole bunch of different square root values here. All of them are irrational. So let's find the smallest one, square root of 35. That's less than 36. So just shy of 6, whole number. So I'm going to put that as my low spot. So here's my 6, which is the square root of 36. And I'm going to check off this first one. Dot right here, square root of 35. And then our largest number, square root of 101. Well, 10 squared is 100, so square root of 100 is 10. And that goes just a little bit beyond that, approaching the 11. So our highest number is going to be this square root of 101, which is going to be just past 10. So put a line here for 10, which is square root of 101. Got that one marked? And now I can put the rest of these in order. So between 6 and 10, we'll have 7, 8, 9. And 7 is equal to square root of 49. 8, which is equal to the square root of 64. And 9, which is equal to square root of 81. So now we have a 41 to mark. Square root of 41. Done. Next, square root of 57. That comes between the root 49 and root 64. Got that one done. And square root of 63, which is going to be right before square root of 64. So make another dot and down. Square root of 63. All right, so we got them all. So now to rate them in order, square root of 35 is less than square root of 41, which is less than the square root of 57, less than square root of 63, which is less than the square root of our highest one, 101, which is right past the 10. All right, that's problem number 4. Next up, problem number 5. Square root of 17, 4, square root of 27, 5, and 6. All right, so let's look at our irrational square roots first. We got square root of 17, which falls between the 16 and the 25, so it's going to be just a little bit over 4. And I have a 4, so let's use 4 as our lowest number, which is equal to the square root of 16. And then we have our next one up, which is right here. My dot for 4, dot for the square root of 17 right here. I like to try to keep track of my numbers, that way I don't skip one inadvertently. Square root of 27 is going to fall between the 5 and the 6. So if I have a 4 up here, I need a 5, which is square root of 25. And we'll take a 6, square root of 36. So we got that one marked right here. We have a 5 marked right here. Square root of 27 is going to be just past square root of 25 and less than square root of 36 or the 6. So now put these in order again. First one we had was 4, which is less than the square root of 17, which is less than the square root of 25 or 5, which is less than the square root of 27, which is less than 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All checks out. All right, one more to go. All right, we have square root of 5. We have 2 squared. We have square root of 10. We have 1 squared. And we have the square root of 0.36. Let me go ahead and put this book down. So first we want to make sure we understand what something squared means. Math teachers always use love letters in their work. So we're going to use x as a representative of any number. X squared would be represented by writing x times x. So any number with the little 2 above it, which is called an exponent, is equal to that number times itself. So there's 2 of them all together. So 2 squared, 2 times 2. Now, in case you didn't know, I mentioned it before in class, every number has an exponent of 1. We just don't write it. So everything starts off with a 1 up there. So as soon as it's changed from 1 to something else, that's when you need to write it up there. And remember, anything to the 0 power is equal to 1. But we don't need to worry about that right now, but always a chance to teach something else, I'll take it. So now let's look at these numbers and start lining them up. 0.36, that looks like our lowest number. So that's even less than the square root of 1. So if we had 0, we could add that up here. Square root of 0 is 0. Square root of 36 would fall between 0 and 1. Let me make sure I pronounce it right. Square root of 0.36. So now I'm going to go ahead and start my number line. It's starting off with 0. And our next one up would be square root of 0.36. And now 1 squared. 1 squared is equal to 1 times 1, which equals 1. So let's put a 1 up here. Make a dot. Make a dot. Got that one. 2 squared. 2 squared equals 2 times 2, which equals 4. So 1, 2, 3, 4. We'll see if that's as far as it gets. So right here would be our 2 squared. So make a dot. Make a dot. And now, what else do we have to chart out? We have square root of 5, which falls between 2 and 3. Square root of 4 and square root of 9 will be between 2 and 3. So we'll have our square root of 5 right about here. And then we have square root of 10, which falls between 3 and 4, but real close to the square root of 9, which is going to be real close to the 3. So go ahead and make a dot right here. This will be square root of 10. So let's make sure we got them all done. Square root of 0.36, then the 1, then the square root of 5, and then the square root of 10, and then 2 squared, which is 4. So now putting them in numerical order again. Square root of 0.36 is less than our next one, which is 1, which is less than square root of 5, which is less than square root of 10, which is less than 2 squared, also known as 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's it. Thank you for watching.